The Tonga Volcano Eruption, Impacts and Implications. The eruption of the Tonga-hunga volcano in January 2022 was a monumental event that has left indelible marks on the environment, climate science, and disaster preparedness strategies globally. Situated in the South Pacific Ocean, Tonga is part of the Pacific Ring of Fire, a region notorious for its seismic and volcanic activity. The Tonga eruption was not only one of the most powerful volcanic events of the 21st century, but also an event of significant scientific interest due to its unique characteristics and far-reaching impacts. The event. The eruption of Tonga-hunga on January 15, 2022, was a catastrophic event that released a massive amount of energy. The eruption produced a plume that reached the stratosphere approximately 30 kilometers high and caused a series of atmospheric shockwaves that circled the globe multiple times. The explosion triggered a tsunami with waves that impacted coastlines across the Pacific Ocean, leading to widespread warnings and evacuations. The sheer scale of the eruption, in terms of both the volume of material expelled and the energy released, drew immediate attention from the global scientific community. Immediate impacts. The immediate impacts of the eruption were devastating for Tonga. The tsunami and the ashfall severely affected the local population, infrastructure, and environment. The ash contaminated water supplies, disrupted agriculture, and caused respiratory issues among the inhabitants. The tsunami waves damaged coastal areas, destroying homes and displacing communities. The eruption shockwaves also disrupted communication networks, complicating emergency response efforts. International aid was swiftly mobilized, with countries and organizations around the world sending supplies and assistance to Tonga. This disaster highlighted the vulnerability of island nations to natural disasters and underscored the importance of global cooperation in disaster response and recovery. Climate and atmospheric effects. One of the most significant aspects of the Tonga eruption was its impact on the global climate. Unlike typical volcanic eruptions that release large amounts of sulfur dioxide, SO2, into the stratosphere, leading to a temporary cooling effect by reflecting sunlight away from the Earth, the Tonga eruption was unique. It released an unprecedented volume of water vapor into the stratosphere, estimated between 100 to 150 million tons. This water vapor has two primary effects. It acts as a potent greenhouse gas, trapping heat, and it facilitates chemical reactions that deplete the ozone layer. The injection of such a vast amount of water vapor into the stratosphere is a rare event with significant implications for our understanding of atmospheric processes. Water vapor in the stratosphere contributes to the greenhouse effect, potentially leading to a short-term warming of the Earth's surface. Additionally, water vapor can enhance the destruction of ozone molecules, thereby expanding the ozone hole. This was observed in the unusually large ozone hole over Antarctica in the months following the eruption. Long-term environmental consequences. The long-term environmental consequences of the Tonga eruption are still being studied. The introduction of water vapor into the stratosphere can persist for several years, affecting global climate patterns. For instance, the enhanced greenhouse effect could lead to temporary increases in global temperatures. Moreover, the depletion of the ozone layer can have significant ramifications for ecosystems and human health due to increased ultraviolet UV radiation reaching the Earth's surface. The eruption also provides a natural laboratory for scientists to study the complex interactions between volcanic activity and atmospheric chemistry. The data collected from this event will improve climate models and enhance our understanding of how volcanic eruptions can influence long-term climate variability. Lessons for disaster preparedness and response. The Tonga eruption underscored the importance of effective disaster preparedness and response strategies, particularly for island nations and coastal communities. The event highlighted several key areas for improvement. 1. Early warning systems. The tsunami triggered by the eruption demonstrated the need for robust early warning systems that can provide timely alerts to vulnerable populations. Enhancing these systems with better sensors and real-time data analysis can save lives and reduce the impact of such events. 2. Communication infrastructure. The disruption of communication networks in Tonga hampered emergency response efforts. Investing in resilient communication infrastructure that can withstand natural disasters is crucial for effective coordination during crises. 3. International cooperation. The rapid international response to the disaster showcased the importance of global solidarity in disaster relief. Strengthening international frameworks for disaster response and recovery can ensure that aid reaches affected areas more efficiently. 4. Community resilience. Building community resilience through education, training, and infrastructure improvements is essential for reducing vulnerability to natural disasters. Empowering local communities with the knowledge and resources to respond to emergencies can enhance overall resilience. Scientific and policy implications. The Tonga eruption has significant implications for both science and policy. For the scientific community, it provides a unique opportunity to study the interactions between volcanic eruptions and atmospheric processes. The data collected from this event will inform climate models and improve our understanding of how volcanic activity influences global climate patterns. For policymakers, the eruption underscores the need to integrate climate and disaster risk considerations into national and international planning. As climate change increases the frequency and intensity of extreme weather events, understanding the potential impacts of volcanic eruptions on climate becomes increasingly important. Policies that promote resilient infrastructure, early warning systems, and international cooperation can mitigate the risks associated with such events. Conclusion. The Hunga Hapai eruption of 2022 was a landmark event with profound and far-reaching impacts. It highlighted the vulnerability of island nations to natural disasters, the complex interactions between volcanic activity and climate, and the importance of effective disaster preparedness and response strategies. As the global community continues to study the impacts of this eruption, the lessons learned will enhance our ability to respond to and mitigate the effects of future volcanic events. By integrating scientific knowledge with policy action, we can build a more resilient world, capable of withstanding the challenges posed by natural disasters and climate change.